All right, good afternoon, everyone. Welcome to episode 7 of the Brevity technical webinar series. This one here should be a goodie. We've got something exciting in store for us today. Today we're going to be talking about the new Technical Specification Standard TS 1170.5, and we want to touch on what that specifically means for commercial interiors. So unlike the first 6 episodes, this one here is going to be more of a interview type webinar where I have Matt Bishop, the founder and visionary of Brevity, joining, and we're going to run some questions via Matt. So I'm going to stop presenting that screen. Matt, are you there?
Yep, sure am, Joe. Happy to be here too.
Awesome. All right, so this is just a quick 15-minute interview with Matt. I'm sure Matt is well aware that there's a new draft of the TS 1170.5 standard, which is the earthquake design actions, and it's out for public comment. And this draft aims to update New Zealand's seismic engineering practices by incorporating some findings over the last few years. And it's going to be interesting to see how this works with the current NZS 1170.5 standard. So Matt, let's jump into some general questions. Could you provide an overview of the TS 1170.5?
Yeah, probably the place to start with this is that it's quite different to a normal standard update. They've done something new and exciting, I suppose. Going back a bit in the history, the few years back, about 2-3 years back, the scientists, they redo the national seismic hazard model. They redo the study that figures out how likely earthquakes are to happen in different places, and they find out that the risks are quite different to what they thought they were. And TS 1170 is mostly about incorporating that new science into our earthquake designs. But earthquake and earthquake design is a big issue for New Zealand, thinking of the Earthquake Prone Buildings Act, say. And it's got a whole lot of repercussions. We can't just willy-nilly go changing our earthquake standards without causing a whole lot of commercial repercussions. And recognizing that, instead of creating a standard draft update, what they do instead is they create a technical standard 1170.5. So this is going to sit next to the New Zealand standard. We're going to have the New Zealand standard 1175. We're going to have the technical standard 1170.5. And it means that the commercial realities of the new standard can be tested before it becomes part of the building code specifically. And I'll talk a little bit more about the time frame of that later on.
Oh, fantastic. Thanks, Matt. Very insightful. You touched on the seismic hazard models there. I suppose as an industry impact, how do you foresee the adoption of this TS 1170.5 impacting the construction industry? And if you could touch on what areas within the industry do you think this is going to impact more for commercial interiors? Does that question make sense?
Yeah. So the having looked at the draft, for comment, which is likely to change before we see it come into play. But having looked at the draft, the main impact is to the underlying hazard factors and the way soil types are dealt with and the way the soil structure interactions are and things like that, which generally results in higher hazard areas requiring more robust design. From the commentary on the draft, it appears that there's a lot of people worried about costs in Wellington, say. it's also addressed some other parts. It's specifically addressed the design of parts and components. And it actually looks like if you're in an area of New Zealand where the seismic risk hasn't changed all that much, the new parts methods will give us more leeway to be less conservative, and our designs for areas where the seismic is the same, our designs might actually get more pragmatic, more commercially sensible. For areas where the seismic risk is increased, well, the part design will increase proportionately, mostly driven simply by the seismic risk increasing. So for areas like Wellington, it could increase cost for seismic restraint design quite considerably. For areas like Auckland and Christchurch, it might have very little impact.
Great. So it says when you Google this standard that it allows designers to voluntarily incorporate new knowledge. Is that just while it's in a published format? And when do you expect this draft to be polished and actually released to the market?
It's went up for draft comment last month. It's closed now. You actually can't even find TS 1170 online anymore. We'll see it appear later this year. The only schedule I've seen sort of show it in the sort of like the July-August quarter, but I have a feeling it'll be closer to November before we see it. And that'll be released as a technical standard, which we can use as an alternative solution to building consent. What that means is it's a choice. You can use the acceptable solution, 117, NZS 1170, or an alternative solution, TS 1170. And we might have the ability to do that from end of this year. And then there's likely to be a 2 to 3 year period. Let's say 1 to 3 years. It doesn't seem to be much certainty around that before TS 1170 gets adopted as an acceptable solution into the building code. So it's quite long timeframes, and the likely impact is that we use it where, in the first instance, where it's advantageous, and we use the old method where it would be detrimental. And we'll figure out through the next period where it works for us and where it doesn't work for us. We'll give that feedback back to the standards board and see where it ends up.
Yeah, I think you've already answered my next question just there. It was in terms of practical terms for more engineers out there, how they should approach the process when using the TS standard compared to the previous standard. You already touched on in the next 3 years it'll be an alternative. So does that mean it's more like the trial and see how it goes before it gets fully implemented?
Yeah, they would actually use the word like a test drive, which is a weird thing to say for a standard, but recognizing that it's extremely hard to see what the impact will be on projects until after we start using it. For engineers, there's some interesting choices. For parts specifically, there's more to consider. We've got part resonance, we've got nonlinear building response, we've got a component reserve strength factor. There's some more lines in the method. One of the most interesting is that ductility for a standard ceiling is set at 1.5. Now that's interesting because 1170 sets it at 1.25 and 2785, the new ceiling standard, sets it at 1.0. So we've got some conflicting things to try and marry together here. You can't pick and choose. If you're using TS 1170, you'll be using a ductility of 1.5. But that contradicts what 2785 says. Not sure how we reconcile that one yet.
Great answer. That made it a lot clearer for me. What challenges and opportunities, like what challenges do you see, Matt, with this as we adopt the new specification, and what opportunities might arise from these changes?
Couple of quick things that I've seen. One is what I mentioned briefly before, the difference between different locations. When we're in this sort of test drive period, it's quite likely that some projects will benefit from using TS1170 and some won't. There's some other standouts. One is that the part accelerations get tied to the building response. So if we've got a extremely ductile building, we can take that into account and therefore lower the part accelerations, which we weren't able to do before. And one other one. Ductility. Long resonance components. Long period components. Think a heavy light at the end of the pendulum. There's special calculations in the part section of TS1170 to allow us to treat that differently and considerably lower the loads on those sorts of parts, because a long pendulum type of light or something like that, it doesn't actually attract much loads. It doesn't move a lot in a building, because the building's moving a whole lot at a whole lot higher period than the light could. So there's a few things I've picked up yet so far, and there'll be more to pick up once we see it come out later this year.
It'll be interesting to see how that plays out. So if I was an commercial interiors installer, maybe a ceilings installer, like what would you say to them, as far as like they're reading this thinking, oh great, another standard, what's it going to mean to them? Are the ceilings, like on average, you said some will be, maybe more conservative, some will be less conservative, but is there going to be much of a change if you're a commercial interiors installer?
The way it's written and the way it's being introduced means that it can be entirely ignored for the first however long. It's not an acceptable solution. It's an alternative solution. If it's a design build project, we don't need to use it. If it's got advantage, we'll definitely be telling our clients that we should be using it as an alternative solution if we can get a more commercially viable design out of it. But probably the thing to watch for contractors will be there will be clients, there will be projects where it's brought in as a best practice measure from the client side. And then certainly if you've done your pricing to NZS 1170, you'd be wanting to check that TS 1170 doesn't change your pricing assumptions. So it'll be an awareness thing for the next few years as well.
It sounds like it could be similar to, I think it was episode 2 when we spoke about C2 rated anchors, and important for installers to look out for those sort of clauses on projects.
Yeah. I think the core thing is that it's not moving fast. This isn't something that people need to be worried about for next week.
Yeah, cool. And the last question I have here is just for the feedback and future. Like, how important is it to get industry feedback during that test drive period and this next sort of few years? And like, where do you see the future revisions going?
The balance between the commercial implications of a change and the scientific or engineering calculations are important to get right, but are quite often missed in new standards and standard design. The long feedback loop on this particular standard is a unique opportunity to make the standard writers aware of that and to make changes. Like, for example, in this new standard, we have something called the component reserve strength factor, which is there specifically to allow to account for the fact that parts and components typically have more strength than we think they do, which sounds like a pretty fluffy sort of thing, I suppose. But if, for example, we find out that that a small change to the resonance, say, of how we design ceilings largely increases the amount of braces we need, then we have the capacity to say, well, shouldn't we increase the component reserve strength factor a bit more to account for that with ceilings, to dial it back down to the right level of risk. So yeah, that's the sort of important feedback in the test drive period is around the commercial impact of these changes.
All right, thank you, Matt. We've definitely covered a good overview of the new TS standard and gone through some technical specifics there, some challenges, what it means to the engineers and installers. I'd like to open the floor. If anyone here does have questions, you can. There is a message chat feature in the Google Meets. Fire away there. We're tracking. We've done the 15-minute sort of Q&A interview with Matt, and we do have 5 minutes to answer any questions if anyone has any. The feature is on, so everyone should be able to send messages there if anyone has them.
Well, if there is a uni Gye, this will go up on LinkedIn and YouTube, and we'll monitor there as well. And you know, maybe the questions are coming once it actually becomes a alternative solution. Once it hits the road.
Quite likely. Well, that sounds like a plan to me. Thank you everyone for joining. Yeah, like always, and Matt just said, we will be putting the video and the summary onto LinkedIn and our Brevity webpage. And yeah, that's it for today. So thank you, Matt, for joining, and we look forward to this one. So keep your eyes posted on LinkedIn. Thanks, everyone.
All right, guys.
Cheers.